All right, here are your ratio notes in my absence today. So a ratio is just a comparison of two quantities, and equivalent ratios express the same relationship. So a ratio really is just a fraction in its simplest form. So there are three different ways that we can represent a ratio. You can see it with a colon. 3 to 2 is how you would read that, or again as a fraction. And so again, we just read that as 3 to 2. So here are some examples. If I have 4 red marbles and 6 blue marbles in a bag, the ratio starts as 4 to 6. And when I simplify this, because 4 and 6 are both divisible by 2, that equivalent ratio becomes 2 to 3. Or if a recipe calls for 2 cups of sugar and 5 cups of flour, the ratio of sugar to flour is 2 to 5. That one cannot be simplified because 2 and 5 are both prime numbers, and so there's no common factors. And so different types of ratios. You have part to part, like 4 marbles to 6 marbles in the bag. Part to whole, which would be 4 marbles out of the 10 total in the bag. Or you can have whole to part, 10 to 4. So whatever is listed first in this wording is what's going to come first with your numbers. So the 2 separates them, and if you just follow the order, you should be perfectly fine. And then again, to simplify, write it as a fraction, find your common factor, and then you can simplify it and rewrite it in whatever form it's asking. And then where do we use ratios? Most often in recipes, you'll see that a lot. Maps that are drawn to scale, speeds, unit rates, those are all ratios, right? Fractions, something per hour, per time, etc. And we just went through all of that, so let's jump into some practice problems. Write the ratio in 3 different forms. There are 5 cats and 3 dogs. So cats, 5 is going to come first, so I can write that as a fraction. That would just be 5 over 3. I can write that with a colon, 5 to 3, or with my words, 5 to 3. And 5 and 3, again, both prime, no common factors, so I cannot simplify it. On to number 2, I've got the ratio of 12 to 16. So if I rewrite that as a fraction, I've got 12 over 16. Both of these are divisible by 4. So I'm going to divide the top and the bottom by 4 to simplify it. And this becomes 3 over 4. And if I put it back in that format that it was originally in with the colon, that would be 3 to 4. Okay, a class has 10 boys and 15 girls. What is the ratio of boys to girls? So we'll start with that one first. Boys is going to come first. That is 10 to 15. And I can simplify that because 10 and 15 are both divisible by 5. So that would reduce to 2 to 3. Then part B wants the ratio of girls to total students. So I've got 15 girls. And to find my total students, I would add the boys and the girls. 10 and 15 gives me 25. So my ratio is 15 to 25. I can reduce that because both of those are divisible by 5. So that becomes 3 to 5. Last one, if a smoothie recipe uses 2 cups of yogurt and 3 cups of fruit, how much yogurt would you need if you used 6 cups of fruit? Keep the ratio the same. So the ratio is 2 cups of yogurt to 3 cups of fruit. I want to know what I would need if I'm using 6 cups of fruit. Well, if my ratio originally starts with 3 cups, to get to 6 cups, I would double this. So that becomes an equivalent ratio of 4 to 6. So when I have 6 cups of fruit, I need 4 cups of yogurt. So that's where your ratios come in handy with recipes, is when you are doubling, tripling, or halving things. Okay, that concludes our notes, and you are now free to start on your Delta Math practice assignment.